Hello and welcome. Today we're going to continue conditional statements B, and this kind of focuses on the truth value. So we're going to still do converse, inverse, contrapositive, and then I believe tomorrow we'll talk about big biconditional forms, and then we're going to determine truth values today. That's the main idea, but we're still going to be doing those things, and biconditional will be tomorrow, and we're just going to figure out what is the truth value. So I'm going to do the inverse, converse, contrapositive really quickly. I already wrote them down just for time's sake because I really want to focus on just the true and false of these truth values or of these conditional statements. So example 1, the table below gives us the shape and color of toy blocks in a certain set. These are the only toy blocks in the set. So a square is green, a triangle is blue, a star is purple, a clover is red, and the circle is also red. So clovers and circles are both going to be red. The rest are all distinct in their own colors. So a conditional statement is given below. So right here, this is our original statement, which you have if P, then Q. So if we know a toy block is going to be red, then the toy block has to be a circle. So we're thinking, does this have to be true given that the block is red? So if we look back at the color, and we look at red, red is also a clover, and red is also a circle. So this is not true. This is actually false on the truth value because the toy block, is in fact not just a circle. It could be the clover as well. So if we look at the converse of this, if we flip it around, so if the toy block is a circle, so we start here, if this is a circle, there's no other ones that are circles, so a circle has to be red. So the toy block is red. This would in fact be true. So the inverse, again, it's saying the opposite of both this and this. If a toy block isn't red, then the toy block isn't a circle. So if a toy block is not red, so if we look at these that are not red, so we just cancel those out and we look at purple, blue, and green, then it's not going to be a circle. So, well, these are not circles, so that is good. So this one is also true. So it's kind of using words and then thinking about not things. Not that, not that. So the contrapositive is, well, if the block is not a circle, so if it's not a circle, meaning it's a clover, star, a triangle, or a square, so it's not the circle, so it's one of these four, then the toy block is not going to be ever red. So if it's one of these four, then it cannot be red. Well, if it ends up being a clover, it is in fact red, so this is also false. And this will actually get to something later when we talk about deductive reasoning. This and this, the conditional statement, the original, and the contrapositive always are the same. Same with the converse and inverse. So notice they're both true, they're both false. That is something that we will talk about later. So let's go ahead and try one yourself. On Alex, it will just, you have to do a drop down, and I have the answers already dropped down in for you. So remember the converse is flipping around. So just a reminder of how this looks. So I'm going to just put my P's and Q's. So this is something that we did yesterday. So if you don't know this, rewatch that video. So converse, if you recall, is if we do Q, then we do P. So it's just flipping around P and Q. The contrapositive is if the opposite of Q, then the opposite of P. So it's the negation of the converse, or the converse of the inverse is doing both negating and flipping. And then remember the inverse is if not P, then not Q. So those are things that you should know from yesterday. So again, rewatch that video. So let's go ahead and read this. So our first thing is looking at this. We have a necklace, a hairpin, a ring, a pendant, and a bracelet. A necklace is gold, a bracelet is gold. All of the other have their own distinct colors. So hairpin's copper, ring is silver, pendant is platinum. So we're going to say if an item has to be a ring, so we know it's a ring, then the item is going to be made from silver. So we go to a ring, it is in fact made from silver. So that is in fact true. So now let's go to the next one. So if the converse, so if the item is made from silver, then the item has to be a ring. So let's look for silver. Silver's right here. Oh, and silver has to be a ring. That is also true. So we'll write that. Now, the contrapositive, if an item is not made from silver, so if it's not made from silver, it means we cancel this out and we have gold, copper, or platinum, or gold. So we have those four. Then, if it's not silver, it has to be one of those. Then the item must not be a ring. So this one goes to necklace, to hairpin, to pendant, and to bracelet. So those are not rings, in fact. So this one also has to be true. Again, something to note is the first original statement and the contrapositive have to match. Those will always be true together or false together. And very similarly, the converse will have to be the same as the inverse. And so whatever it is. So this should be true. Let's just double check. So if an item is not a ring, so it's not this, therefore it's a hairpin, necklace, pendant, or bracelet, I'm guessing it can't be silver then. So then the item is not made from silver, so that is in fact true. So that's how we walk through those truth value tables. So let's talk about something called the biconditional statement. I did say we're probably going to do this in the next lesson. It's actually on this lesson. Woo! So biconditional statements are logical statements that combine both the converse and the original conditional statement into one single statement. That means they both have to be true together or they both have to be false together. So just something we're going to highlight. We're going to do if and only if. It's what we're going to use, but it combines the converse and a conditional statement together into a single phrase, and they're either are both true, they are true together, or they're false together. So it's got to be all or nothing. So in this case, a biconditional statement is true when both the conditional statement and its converse is true. So if we go back a slide, all of those were true, therefore it could be biconditional. And we're going to use P if and only if Q. And one thing to note is what I like to write is P-I-I-F-F-Q. And I know I jumped to uppercase here, so you can use lowercase or uppercase. It's not that big of a deal for this part. I've always liked traditionally using lowercase, but I know if you look on your homework, it will use capital letters on this example, which is kind of silly because I use the lowercase. But whatever. But this IFF right here, and now let's highlight this in green, this IFF represents if and only if, that thing right there. So that is something to know because when we have IFF, you should just auto assume it's biconditional. And that is something you'll see throughout all of math because that is something as you go further, it is used quite often. So let's do an example here. So the table below gives the number of calories for each type of candy in a certain box. These are the only types of candy in the box. So we have peppermint, chocolate, butterscotch, caramel, cinnamon. And these are the number of calories for each of them. Notice how chocolate has 250 and cinnamon has 250 as well. The rest are all distinctly different. So our conditional statement, a candy is caramel or caramel if and only if the candy has 300 calories. So we're going to write its conditional statement and then write its converse. So the idea is notifying where it has if and only if. So what we do is this part is going to be my P, and this part over here is going to be my Q. So when we write this conditional statement, we're going to write if P, which if a candy is caramel or caramel, whatever you like to say, then we're going to write our next part of it. It flows logically. Then the candy, or then it, has 300 calories. So that would be my conditional statement. Now we're going to figure out is that true or is that false in just a moment. And then what we have to do next is we're actually going to flip these around. So we're going to do if and then again. But we're going to now write if the candy has 300, oh, sorry, I got to rewrite that. So has 300 calories. Then the candy, then it, I'm just going to say then it is caramel. So that would be my converse. It's just taking the red part, putting it first versus last. So remember, converse, flip it around. Now, we're going to figure out, are those true? If they're both true, we can write it as a conditional statement or just say they're true, or that conditional statement is true. So the IFF, or if and only if, is the biconditional statement. And it needs to both be true or both be false for this to work. So in this case, let's look at it. So the conditional statement, if the candy is caramel, so let's go to caramel, it's 300 calories. Oh, yep, that's true. So let's write that down. This is true. Now let's look at the next one. So if the candy has 300 calories, let's look there. There's only one of them, and then it has to be caramel, so that is also true. So therefore, this is true. Again, this could be both. Both need to be true. In this case, both need to be true. Be true. Again, they could both be false for it to work as well, but I don't think you'll see an example like that. So we're going to continue on and have you try this one on your own as our last and final thing. So please try this. I'm going to have it paused and you can do that and I'll have an answer shortly. So hopefully you have this down. So again, you write the first part as the if, the first part of the conditional statement, and then that's your P, or your, sorry, Q. So it's if this part, then this part. That's how it should go for your original statement. Flip them around, so put the red part first and then the blue part second. Now, are they true or false? So if an item is made from gold, so we look for gold, well, gold is going to be a bracelet or gold is going to be a necklace. So then that is false. It's not just a necklace. It could also be a bracelet. So that has to be false. So is the converse true? Well, if the item is a necklace, which there's only one necklace, then it has to be made from gold, which that is true. Those are different from each other, so it's false. So again, if they're both true or they're both false, we would say this is true. So these are different. These are not the same. So it's going to be false. Now, if they are the same, again, it could be false and false. Therefore, this would be true. They just have to match in order for this to be a biconditional statement. That is true.